polynomial long division, and this is a problem I'd like you to, if you want, just put your markers down and watch this happen so that you don't have to go back and forth. And we'll do another example where you can kind of play along. The first thing I look at is I consider this first term here and this first term in the dividend. This one is an x. This one is an x squared. I want to ask myself, what would I multiply by to go from x to x squared? X times what equals x squared?
X times x.
X times x. So I'm going to put that x here. You notice where I chose to put it?
Above the 7x.
I put it above the 7x because my x's really need to line up and match. I didn't put it above the x squared because my x that I chose to put here doesn't have a squared on it, right? So it's important where you line those up. Now, how did I know what to subtract when I did regular division?
Because,
When I subtracted something, I got that thing.
That's like x times what equals this.
Right. So I'm going to take the first part of my quotient, that x times this divisor, x plus 3, and then that number will tell me what I'm going to subtract.
I'm already confused.
X squared plus 3x.
Yes, perfect. X squared plus 3x, right? Because I distributed this x times the x, that gives me x squared, and then x times the 3 is 3x. And I'm going to subtract all of that. So far, this feels just like we did with numbers, right?
No.
Not at all.
No.
Okay. So
That was like in sync.
I chose to put an x up here because x times x would give me this x squared. So I chose that very carefully so that these would be exactly the same. If these aren't the same, then you made a mistake. You've either chosen the wrong guess for your quotient or you multiplied wrong here. At this point, I'm ready to subtract. When I subtract this polynomial, don't forget you have to distribute that subtraction. If there are mistakes that happen, they're almost always right here. When I subtract, this becomes a negative x squared and a negative 3x. Then I have 7x and a negative 3x that together combine to a 4x.
Where did that 3x come from?
I took this x times x and this times a...
Why did you?
Because to know what I subtract, I have to take x times this. Just like when I took the 8 times the 12 in the daily math problem, to know that I subtracted a 96 in that next step. I can come back and show you that when we get to this problem.
Yeah,
I'll compare it again. My next step here is to bring down this 12.
So could you just like take that divisor and times it by 4, so then it could be 4x plus 12 divided by 4?
Yeah, now I'm going to say, how do I make this x look like this? 4x. X times what equals 4x? Jimmy, what do I need to multiply by?
4.
By 4, right? To go from here to here, x times 4 gives me 4x. So I write that up here. It's a positive 4. Notice that my number is above this plain number here, so they're lined up correctly. Now I'm ready to say, let's take the 4 from my quotient times this, x plus 3, and I'll get something here that I'm going to subtract.
It's going to be 4x plus 12.
Right, because 4 times x, distributing, 4x. 4 times 3 is plus 12. Now I'm subtracting all of that, so I'm going to change this to a negative 4x and a negative 12. Well, those both add to 0, right? No remainder. So I'm guessing that x plus 4 times x plus 3 should equal what's underneath this division box. Yeah, let's check it. So the quotient times my divisor should give me the dividend. Is this going to work? You betcha. So x times x, outside is 3x, inside is 4x, and last is 12. These two add together, to be 7x. Does it work?
Yep, but I still don't really understand.
Hey, you guys know.
It's okay. The first time you've seen it, how could you understand it? You can stop. Thanks.